Hi everyone, let us discuss this example. See, in this example they have given y and we have to prove these two equations, right? So y satisfies these two equations, this thing we have to prove. So let us start with y. What we have y is equal to a cos ln x, that means log x, that log x, plus b sin ln x. So as you can see here, y2 is there, highest derivative is second derivative, so that's why I will find first two derivatives and we will try to prove the first equation, right? So let us differentiating with respect to x. So derivative of y is y1, a is constant, derivative of cos is minus sign, so minus sin ln x. But see, again using chain rule, I should take the derivative of log x, which is 1 by x, right? Plus, let us find its derivative. B is constant, derivative of sine is cos, so that's why I should write here cos ln x, but again derivative of ln x, that means log x, derivative of log x is 1 by x. Okay, so first derivative we have got, so now we have to go for the second derivative. But see, we have x at denominator, so if you directly go for the second derivative, the problem will be very complicated. Since there isn't something in denominator, that means we should use u upon v formula. So for that, to make it more simple, what will I do? I will multiply both sides by x. What I am doing? Multiplying both sides by x. See, let us see what will happen. If you multiply it by x, x y1. If you multiply it by x, that 1 by x and x will get cancelled and simply you will have minus a sine log x, right? If you multiply this term by x, x will get cancelled and you simply will have b cos log x, right? So now we will go for the second derivative. The problem will be more simple now. Okay, differentiating with respect to x. Okay, so let us use the space to write. Just a minute, I'm writing there. Okay, so now we have to differentiate with respect to x, but there is a product of two functions, x and y1. That means I should use u into v formula. First into derivative of second plus second into derivative of first. X as it is, derivative of y1 is y2, derivative of y1 is y2, plus y1 as it is, derivative of x is 1. So that's why I will not write anything. Derivative is 1, no? So y1 into 1 you will have y1. So this is equal to, let us go further. Let us come to the right hand side now. We have to take its derivative. Addition is there, separate derivative. Minus a is constant, let me write as it is. Derivative of sine is cos, so that's why I should write here cos log x, but derivative of log x is 1 by x. Chain rule I use again, getting? When you have one function inside another function, we have to take the derivative of inner function again, so we call it as a chain rule. Let us find the derivative of second term. B is a constant, let me write b as it is, b. Derivative of cos is minus sine, so I should write here minus sine ln x, that means log x, and derivative of log x is 1 by x. So again that 1 by x we have got there, getting? So it is looking little bit complicated, so that's why I will multiply both sides by x. What I am doing? Multiplying both sides by x. If you want, you can write the sentence here, multiplying both sides by x, but I am doing it directly. If you multiply both sides by x, here you will have x square y2. If you multiply it by x, you will have x y1. If you multiply it by x, x and 1 by x will get cancelled, minus x cos log x, right? If you multiply it by x, 1 by x will get cancelled, minus b sin log x, right? Did you notice we can take minus sign common? We can take minus sign common, so therefore x square y2 plus x y1, I am taking minus sign common, a cos log x plus b sin log x. But a cos log x plus b sin log x, we have seen it somewhere. Yes, this is nothing but our y. So this bracket can be replaced by y, since this is the value of y, getting? So this is equal to minus y. Let us shift this y on left hand side. So what will we have? So therefore x square y2 plus x y1 plus y is equal to 0. I think same thing we want, no? Yes, we got it. So the first part is proved now. We should go for the second part. To prove the second part, I should find nth derivative. As you can see here, yn plus 2, n plus 1. So everywhere we have got n. So I should go for the nth derivative. Differentiate, or I will simply mention taking nth derivative of both sides. Taking nth derivative of both sides. Taking nth derivative of both sides. Let us take, there is no more space to write. Make a screenshot of it first, then I will go further. See, let us take nth derivative now. See what will we have? X square y2 nth derivative plus x y1 nth derivative, and derivative of nth derivative of y is yn. Derivative of 0 is 0, you know. Okay. So see, there is a product, so I should go for Leibniz rule. I should go for the Leibniz rule to find nth derivative. Let me write it here. What is that Leibniz rule? When you have two functions uv, then nth derivative can be calculated in this way: vn plus nc1 u1 vn minus 1 plus nc2 u2 vn minus 2 plus nc3 u3 vn minus 3, and so on, and finally we will have ncn u nth v only. Getting? So this is the Leibniz rule. When we have the product of two functions and we have to find nth derivative, then I should go for this rule. So here also I will use the first rule. Getting? So this Leibniz rule. So for first bracket, as you can see, our u is x square, right? And our v is y2. Let us apply the Leibniz rule. So u as it is, and nth derivative of, right, nth derivative of v, that means nth derivative of y2, plus I should write nc1, as you can see there, nc1 u1, that means derivative. So derivative of x square is 2x, right, and y2 we have to take nth minus 1 derivative, so n minus 1, right, plus I am simply following that rule, nc2 u2, that means it's one more derivative. This is our u, we took first derivative, now we have to take second derivative, so it will be 2. Okay, and what I should write here, y2 n minus 2 derivative, right, n minus 2 here. After that we should go further, nc3 u3 means it's one more derivative, but you know that when you have 2, its next derivative will be 0. Okay, 2 is a constant. Initially it was x square, its derivative is 2x, next derivative is 2, next derivative will be 0, next derivative will be 0. So all remaining derivatives will be 0. Getting? No need to go further, since after that remaining derivatives will be 0. So this process will terminate here, it will stop here. So yes, we finish the first nth derivative of first term is finished here. Okay, let us go for the second. For second also I should do the same. I should go for the Leibniz rule, because there is a product of two functions. What is our u? Our u is x. What is our v? Our v is y1. Okay, so let us apply the formula. U as it is, x as it is, y1, I should write here nth derivative, plus next nc1, getting? Derivative of x is 1, and it's n minus 1 derivative, y1 n minus 1. Getting now? So simply whatever the function we have, what is our u? We should take its successive derivatives. Derivative of x is 1, derivative of x is 1 I have written, derivative of 1 is 0, next derivative will be 0. So all remaining derivatives will be 0, so why shall we write further? The process will terminate here, since all remaining values will be 0. Yes, that is over. Nth derivative of second term is also over, and the next term is yn is equal to 0. So now simply we have to simplify this one. So it's x square, second derivative and nth derivative, that means simply we have to add them, n plus 2. You know the value of nc1, it is n, its value is n, so it is 2nx. I directly wrote this n and this 2nx, and simply you have to add them, so it is 2 plus n minus 1, that means n plus 1. You know the value of nc2, it is n minus 1 by 2. Value of nc2 is this one, into 2, simply you have to add them, so yn, okay, yes, plus x, you have to add yn plus 1 plus nc1, we have written already, nc1 value is n, so this n you have to add, so it is yn, and yn is equal to 0. Okay, Yes. See, there is no more space to write. Let me remove that part. Make a screenshot of it, then I will go further. Okay. See, x square yn plus 2, right? We have two terms of yn plus 1, yn plus 1, yn plus 1. What can we take common from these two terms? See, we can take yn plus 1 common here. We can take x also common. X also we can take common. So in bracket we will have this 2n and this 1. That means I can write 2n plus 1 x y n plus 1. Let us simplify it. 2 will get cancelled. This bracket will be n square minus l. I solved this one. I multiply each term by this n and 2 cancel. That means yn. Here what will happen? Let me write as it is. N and y is equal to 0. So therefore x square yn plus 2 plus 2n plus 1 x y n plus 1. Can I take yn common? Yes, definitely we can take yn common. So we will have n square minus n. Here also we can take yn common, n, and if you take yn common, you will have 1. Yn is equal to 0. So x square yn plus 2 plus 2n plus 1 x yn plus 1. See, n and minus n will get cancelled to each other, right? N and minus 1. We really feel happy if some terms will get cancelled. Getting that means it indicates that we are in the right track. We are on the right track. Okay, so n square plus 1 yn. So tell me, is it same as given equation? Yes, same, right? No, it is same as the given equation. So therefore, this is the required answer. Yes, in this way we proved this part. Make a screenshot of it, then we will stop. Thank you. Bye bye.